So off to the side of problem 1 in your review packet, the review packet says HPC, final review problems. Number 1 involves union and intersection. Okay, so I would encourage you, I'm going to give you little tips for each one, and the tip I want you to write down next to one is graph on number line. The other little tip, write that down, that's the point. I'm giving you tips that you should probably write down, because you're not going to remember when we go through 12 of them what I said about number 1. Graph it on a number line. And this means union, which is like all of the things that are included, like when on number 1a, they say 1, 2, union 3 to infinity. When it says union, that means all of them. So it's 1 and 2 and all the other ones, 3 and 4 and 5 and 6 and 7, except what does number 2 have on it? The number 2 has a what on it? A parentheses, and what does that mean? Not included. So in other words, if you have like a 2, 5 where the 2 has a parentheses, a bracket means included. Union means all of them. What does this thing mean? Intersect. And yes, the word and works, but I really think intersect is a better word. It's like where two things overlap. All right. For problem 2, the hints I want to give you to write down next to problem 2 in your packet. It's got a triple Venn, and I just want to do what I'm going to call 2B. I'm making you a new problem over here. Make me another triple Venn, A, B, C. And everybody remember these, where you go like A intersect B union C. Everybody try to shade in what that answer is. And then compare it with the kid next to you. We're making up a new problem 2B to help you with problem 2. Okay, so here's A intersect B. Did you know that you should start with that? That's where A and B intersect. Make sense so far? Okay. Now how about union C? Well, I'm gonna just shade in all of C right now. And your eye will probably be drawn to where they intersected, but that's not what I wanted. I wanted the union. Therefore, the final answer is what I'm going to circle in blue here. Raise your hand if you agreed with me on that. Okay, cool. Now, I will admit, it is harder to do number 2 because they have shaded in an area, and you have to go backwards. So I'll just help you. Look at number 2 in your packet. Would you agree that it's mostly A? Am I going to union that with something else? No, because if I union that with something else, it's just going to get bigger. So I got to somehow do an intersect for sure to somehow get this answer. So that's all I'm going to say is A's got to be included. Intersect has to be included somehow. And it isn't just a simple intersection of A and B. All right, so don't say the answer. There's an answer key, and it's going to be posted. So this is not going to be a mystery, but try hard, and then you can look at the key. Now I'm going to let the guy at the door be next.
Hello, I'm looking for...
I know that one is a tough one, but we need to move on. On number 3, they ask you to find the inverse, but just the range of the inverse. Do you get that for number 3, you really just need to find the domain and range of the original one, because then you can flip-flop them over and you'll know the domain and range of the inverse because they're just a reverse. So can everybody just find the domain and range of the original? Just put this down as your notes for yourself for number 3. If you just find the domain and range of the original one, then the inverse is just going to follow. They're not asking you to graph the inverse. That'd be way harder. That'd be a reflection over the line y equals x. But this is just what's the range. So you just need to know the domain of the original and it'll be easy. Okay, moving on. We're just going to have a brief tip for a lot of problems. Moving on to number 4. On number 4, they ask you to find f of -4, and oh my gosh, if you can't stick a -4 into the f function, we're going to really struggle on this final. And the same with putting a half into the g function. That ought to be pretty easy. But c is definitely up a whole nother level. It starts with f of x and then it has it squared like this. Do you get, they didn't tell you anything to put into f of x. They would just want you to take all of f of x and put it in there and square it. Okay, so that's what you're going to do on letter C, is you're going to stick f of x right here, and you're going to square it. And then you're going to figure out 2, and I'm going to put g of 3 in a different color. I'm going to make it red. Do you need to find g of 3 first, and then you can just stick it in there and times it by 2? Okay, so you're going to, first thing I'd do is put in something here, put in f of x there. Then I'd figure out g of 3, and I'd put it there. All right, so there's my hints for number 4. Number 5. For number 5, I want to do one of those problems off to the side. Would you make a 5b? I'm going to give you a problem, and I want to see if you remember this. If I put a negative 3 parentheses x minus 4 parentheses squared plus 8, can you name each of these things and what they do? Hint, one of them might be like vertical shrink. One of them might be like horizontal move to the left, that kind of thing. I'm going to pause for a second while you try 5b, and that'll remind you of all these little rules, like if it's on the inside, it does the opposite of what you'd think. Horizontal stuff's on the inside, vertical stuff's on the outside. All right, so I'll give you that answer in just a second while you do this new made-up 5b. Okay, Miss Silver, can you tell me some of them?
Plus 8 moves the function up 8.
Up 8.
The minus 4 in the parentheses moves it to the right 4.
Right 4, correct. What's that high vo stand for again, Sophia? High vo, what does that stand for again? Horizontal on the... Horizontal on the inside and vertical is on the outside. That's what that stands for. I didn't say you had to do that. I'm just asking if you knew. All right, on to Nick Voves. What's the negative in front do? Why don't we use vertical or horizontal? Which one is it? It's a vertical reflect. I would not be able to accept flip in this class. I probably would if I was in regular pre-calc, but in honors you have to know it's a reflection. Put cell phone in the backpack. Okay, and the 3. Lillian, what's the 3 do?
That's a vertical stretch.
Vertical stretch. Very good. Okay. There's 5b. That's meant to help you with problem 5. You're going to be making a function that moves 3 to the right and reflects over the x-axis. Given that they want you to use x squared, it'll look kind of like b, like what we just did. It's a quadratic. All right. Number 6. There's 2 ways you could do this. I'd like you to take notes to say you could complete the square, and you could also do negative b over 2a, comma, do you remember the rest of the equation for the vertex? F of negative b over 2a. Okay. Taking notes on this? Good. Number 7. Oh, wait. And for number 6, let's just see if you can complete the square. I'm going to give you one. X squared plus 4x plus 1. Now, that wouldn't factor, so that takes one of your tools off the table. But do you remember how to complete the square? Hint, half and square. You move the plus 1 over a notch so that you have some room. And then you do half of this and you square it and you put it here and here. It's ringing a bell. One of those things you've already done and been tested on but it's kind of slipped through the cracks, I think. But if I remind you right now, good chance you'll be able to do it again on the final, and again, that makes you hold on to it a lot longer. This is why we do semester review like this and then a final, because it'd be easy for something like that to just slip away. All right, I'm going to call on Saloni. Can you do the half and square part for me? So I put a +4 here and a -4 next to it because we want those to cancel each other out. Then the part I just put parentheses on would be able to factor, which would turn into x plus 2 times another x plus 2, so quantity squared, and these two together make -3. Why'd we do that? Because look, vertex. Remember that the vertex is right there, and the vertex would be -2, comma -3. Why did I change the one on the inside? Because I don't trust it. -2, -3. That's the vertex. Now, that's not the one that you have one to do now too. But I gave you number 6, this extra practice problem here. This was 6B. That was not the answer to your problem 6. Your problem 6, of course, is different. But you could use complete the square if you'd like, or you could use -b over 2a. And then f of -b over 2a. That also works. It gives you the exact same vertex. I personally think complete square is a little easier. All right, on to number 7. I'm going to remind you about limits. If I say limit of the function as x approaches something and it equals something, I'm going to put a question mark here and a question mark here. When you're first teaching limits, you usually just do infinities because it's easier. So I'm going to show you one. This is 7B right now. I'm making up a problem. I know this is not what they asked you, but if I gave you a problem that did this, do you get this one's heading towards infinity, comma, infinity? I wrote those too funny. I'm going to erase them. If so, then if I was writing a limit about that end, I would say x is going to infinity and y is going to infinity. That would be the limit for this right end. Can you write me the limit on the left end? You always say limit of the function as x approaches, but there's 2 question marks again. The blue one and the black one. Can you tell me how to finish that? Carter Krebs, the black question mark right here. What do you think x is approaching on this one? Louder. Negative infinity is correct. And the other answer is what y is approaching. Ashana. So y is how high it is. Do you agree that it is heading downwards? You sound all like uncertain, so I'm just talking you through it. It's going down, right? So it's going, eventually it'll go way down. So what do you think the final answer is? Negative infinity is correct. That's the limit for this left end of this function. Okay, that's how you do a limit. So one more thing I got to teach you for number 7 is if they give you this, I'm going to give you a different one. This is 7b again, or this is actually like 7c. Negative x to the 6th plus 4x minus 10. Here are 3 things I know about this. Down on the right, do you guys remember that? If you don't, you absolutely should be taking this as a note. This is the what? The last number?
Constant.
Yes, it's called a constant. That is true. But that's not what I was going for, but I'm going to write it down because it's a good point. And what else is it? The y-intercept. Very good. The y-intercept is where x equals 0, and if I put a 0 into those x's there, it would leave me with negative 10. So that's the y-intercept. What is the 6? There's a name for it. It's called the degree. Okay, and it tells me the other end. Like, it's down on the right. I never said what it was on the left. Well, this doesn't tell you the left. It tells you whether it's going to be the same or different. That's what it tells you. And if it's an even number, what does that feel like to you? Same or different? Same. And it is. This is telling you that it's the same because it's even. And if it was down on the right, it's going to be the same. So it'll be down on the left. All right, so there's some help for number 7 and everything you need to know to be able to like sketch it and then write the limit. There's actually 2 limits you'd do in number 7. Okay. So, number 8, we're going to just try to do this page and one more page. So we're going to go fairly quickly here. On number 8, do you remember the rate plus the rate equals the total rate kind of question? I did problems just because it reminded me of my mom and dad who have passed and wonderful people. They brought me up north and would pick blueberries. And so I'm going to say this is Bob's rate. This is Sally's rate. And my mom was amazing at blueberry picking. Nobody would dispute it. 1,000 per, let's say, an hour. And my dad, let's see, he was at 40 berries. I'm going to label these because units matter at first. In 2 minutes, but it's still not going to compare to my mom. So, do you remember these deals where we would say, how much can they pick total together? Well, what's one flaw with how I wrote this? Yes? Ones and hours. Ones and minutes. Do you get how we'd probably need to fix that? So I'd have to change my 1 hour into 60 mins. Now I've got something I can actually add. Okay. So together, how many blueberries do they pick? In, let's say, 2 hours. Okay, so then I don't know this total, so I'm going to call it T for total. Over, let's say they want, how many would you pick in 2 hours? That's a typical setup of one of these rate plus a rate equals a rate questions. This is, again, assuming you wanted to know how many blueberries would they pick together in 2 hours. And you'd solve for T. Make sure you keep the units the same. Like if they're going to use minutes here, you got to use minutes there. And you got to use minutes there. And then you put the variable in only in the spot that you don't know. I don't know what their rate would be for 120 minutes. All right, so that's a typical way to do number 8. All right, moving on to number 9. It's logs. My tip for you on number 9 is, do you remember, and you have, let's do a simple one. We're going to call it 9b. Go off to the side and remind yourself that if I have log base 2 of x minus log base 2 of y, it condenses to, don't say it, write it. Write that problem. We're going to be done real soon. Stay focused. Write this example problem for yourself. Try to answer it. Nico, do you remember how to do these?
Yeah.
Log base 2 of?
X divided by y.
X divided by y. Very good. Now, look at 9 again, the one you have in your packet. Do you guys get how there's 2 subtracts? The first subtract makes a fraction. The second subtract makes another fraction. Do you get it? Would be kind of like if I said divided by something else. Like if I divided by 3 here. And then you got to go, oh, so that's like a 3 over a 1, and then you flip and multiply. But there's going to be 2 divides because there was 2 subtracts. I'm not saying that's your answer. I'm saying it'll have that in it on number 9. Okay, number 10, just write the word rewrite. Next to number 10, write rewrite. Because that's where you're going to take a log and get rid of the log. And you could also call it the circle of logs. And that's kind of like this. I'm not doing the same problem, of course. This to the that equals that. You remember those? Rewrite was key. You'll do something like that on problem 10. Problem 11's tip. You just have two more after this. Is if you have log base 3 of 3 to the 8th, do you get the answer to that would be 8? And this is the principle where I was saying make the bases the same and then the answer's already there. You get out of the bases are the same. One's the base of a log and the other one's a base because it has a power on it. So these are both in a way bases. Okay, so then the answer is the exponent there. Then was another kind. Let's say we had 8 to the power of log base 8 of 6. The answer to that would be 6. Once again, the bases are the same. Therefore, the answer is already there. One more thing about logs. Do you remember if it doesn't have a base, it'll become all about the base? What if there's no base? What is the base? 10. What if it's an ln and that doesn't even look like a log? Log base e. All right, good. Okay, so there's some hints on logs. Number 12. Number 12, I want to remind you, they give you a bunch of points. So let's do 12b, and I'm going to make you one. Everybody write down these 2 points, 2 comma 3, and 8 comma 4. Do you remember how to make a slope for that, first of all? Why do we need that? Because y minus y sub 1 is going to be equal to m, which is the slope, times x minus x1. If you don't have that one memorized, you'd want to memorize it because we don't give you this one. It's considered too easy. You're supposed to know this one. We do give you some formulas on the test, like complicated ones, but this is one you're supposed to know since algebra. It's called point slope. And a reminder, you'd go 4 minus the 3 over the 8 minus the 2. And then in your x and your y spot, here and here, I'm going to put in x could be this, and this is the y. It goes right there. So y minus 3 equals 4 minus 3 is 1 over 8 minus 2 is 6. X minus, and the x of that was 2. And there, that's totally fine to leave it this way. I think some people don't feel like they're done until they solve for y, but it doesn't say you have to solve for y. Okay, number 13. Last one we're covering. Everybody focus. We've got one last one. Look at number 13. I'm going to give you 13A and 13B. No, I'm going to give you, 13B and 13C. My point is 13, you already have a problem, 13. But I'm giving you 2 kinds of things you have to know to be able to handle 13. What if you had a problem that had the square root of x minus 3 and they wanted the domain? Do you guys remember how to do domains when you have square roots? Did you set x minus 3 as something, what is it again? Greater or equal to 0. So you set what's underneath the root to be greater or equal to 0. What if you have something like this? Then you say x cannot equal what? 5. So there's 2 kinds of domains. The stuff that's underneath the square root, which you will set greater or equal to 0, and the stuff that is on the bottom of a fraction, set those not equal to 0. So x cannot be 5. I could have technically said x minus 5 cannot equal 0, and then I could have solved it, and I'd get x not equal to 5. All right, that's a reminder of how you do domains. All right, we've made it through number 13. I will give you more tips for the rest of the packet on a future day. So the rest of today is just me helping you review for the quiz tomorrow. So this is the part where we're going to actually take a short break so you can just let your brain rest for a little bit. talk to a friend for a few minutes, then have a blank notability doc out, and we will prep for the quiz after a short break. Okay, so imagine it's tomorrow and I hand out the quiz. It's going to be on paper. Okay. And then you will type it into a Schoology quiz to get an instant score, which is kind of cool. At least that's the current plan. Let's say I started with this. 2 times 3 is 6 times 3 is 18, dot, dot, dot. What if I asked you for the, let's say the 6th term without a calculator? Well, you'd have access to the formulas. You see them on the board right now in the room. But for those that are at home today, in case you forgot, we'll recite what it is. Gwen, can you tell me which formula this is? And first of all, you probably want to decide, is it arithmetic or geometric? Good. And did I ask you to add a whole bunch of things up? Okay, so then that decides it. Which formula is it? Read it. Okay, good. Now we're going to put in the numbers. Saloni, tell me if I'm doing the 6th term, it's a sub 6, and we really can't do anything else yet over there because we don't know the answer. But what else can I put in for the 6? Yep. So that'll be a 6 minus 1. And what's the a, Saloni? No, the a is what you start with. 2. The rate is the 3. Okay, so this is 2 times 3 to the 6 minus 1 is 5. 2 times 3 to the 5th. Raise your hand if you had that one right. Okay, good. Any questions about that? All right. Let's do a different one. Let's do the formula that adds all those 6 terms up. Okay. Which formula does that? Well, on the board, you can see the geometric formulas. It must be the other geometric formula. And I'm hoping you guys can all see S sub n, that's the sum of them, is a times 1 minus r to the n over 1 minus r. Now, knowing what a and r and n are, we're doing the sum of the first 6 terms. Would you please figure out the answer? And yes, you may leave the answer with like a 5 to the 3rd power in it or something like that. Pausing. So a in this case is 2, and then 1 minus r, which is 3, to the n, which is 6, all over 1 minus r, which was again 3. So then I have 2 over a negative 2 here, and a 2 over a negative 2 can simplify down to just a negative. So then it's negative, or negative 1, times 1 minus 3 to the 6th. So then if I'm going to distribute that negative out, it would be negative 1 plus 3 to the 6th. You guys were correct. Nice job. Okay, so let's do one more challenging one that got up some people last hour. This is 7, and this is 9, and it seemed like, well, that's easy. You're just adding 2 each time. But no. If I tell you it's not arithmetic, you have to figure out what this is.
I thought you liked
Yes.
us. Should you leave it like this, or do you multiply it out?
On the test, the numbers will, if they are that hard, you would be able to leave it like that.
Oh, no calculator.
There's no calculator.
Did you say you're gonna test the equations or not?
I'm not promising to give you every equation ever, but I did say that you would be given some equations.
This test?
The quiz they're taking tomorrow.
These are the ones on the board.
Yeah, the ones that are on the board will stay on the board. You just have to be careful. If you say, are you giving us the equations? I'm not promising to give you every equation you ever wanted.
The numbers plugged in to give us our exact answers.
All right. So on this one, I think you can tell this must have been geometric then, right? So you must be multiplying by something. I'm just going to give you one hint for the few people that I see that look a little confused. It's called a common ratio. That should help you. And once you know what that is, you're multiplying by that number here and here. Just make sure it works, you know? Like if you can get it to go from 7 to 9, then you got to figure out the blue question mark times whatever this magical ratio is will give you 7. I'll pause for a second, give that one a shot. Okay, we're kind of running low on time. Can you guys tell me, isn't it 9 over 7? Isn't that the magic number? And if you put 9 over 7 here and you say, what's 7 times 9 over 7? It's 9, yay. So then if this has to be 9 over 7 also. But then you got to think to yourself, what would have to go here? And if I want the answer to come out to 7, then I'm going to need a 9 on the bottom to cancel that 9 on the top. And if I just put a 7/9 here, that's actually going to equal 1. And I don't want it to equal 1. I want it to equal 7. So I'm going to times it by 7 one more time. That way, one of the 7s will cancel the 7 on the bottom, one of the 9s will cancel the 9 on the bottom, and I'm left with a 7. So 49 over 9, raise your hand if you had that one right. Okay, cool. And I want to encourage you to do there's a little quiz in there that you can do for practice for tonight, and there's a key for it. So you should have no excuse of not knowing what you should do to practice. There is a practice quiz in there. Give it your best shot, and I'd start doing your yellow packet. Be nice to later you. That's all I got for you for today.